Welcome to Chapter 7, Vitamins. There's a lot to cover in this class, so the live lectures are fairly lengthy, but lots of interesting information, and hope to dispel some myths and to give everyone a better understanding of the roles of water-soluble, fat-soluble, and the needs for vitamins. So the introduction to this chapter is actually very interesting. It's talking about the incidence of multiple sclerosis, which is a degenerative neurological disease in which the protective layer around the nerves, the myelin sheaths become damaged. And this disease does occur around the world, but more cases are reported in northern and southern latitudes than near the equator. And this has prompted a lot of scientific investigations to look into the factors that might contribute to the distribution of this disease. This picture is of the extreme north edge of the Scottish mainlands in an archipelago called the Orkney Islands. And these islands actually have the largest concentration of MS in the world. What the book says and studies suggest that about 1 in every 170 women suffers from this condition. And they do believe there is some genetic predisposition to the likelihood of women having MS, but they also find that in these areas where they don't have as much sunlight as they do as people get closer to the equator, they find a deficiency of vitamin D. Now, typically, vitamin D is made in the body with, when exposure to sunlight is available. Like here in Florida, we really don't have issues with vitamin D deficiency. But in northern and southern areas of the world, their sun is limited by shorter winter days and frequent cloud cover. And we've seen that these people in these areas have deficiencies in vitamin D. So what's happening with the governments in these areas as they are, typically the diets were high in fish and eggs, but because they were traditional diets, and as food consumption changes in more prosperous nations, we find that people are consuming more processed foods and less vitamin D. And what their governments are planning on doing is starting fortification of milk with vitamin D, and we know that that's a common practice in the United States. And the purpose is to ensure that their populations are getting enough vitamin D to promote better health and perhaps prevent these high incidents of MS. So what we're going to talk about is vitamins, and when we say vitamins are organic, we mean that they contain carbon. And when we get to minerals, we're going to find out that minerals actually are not organic because they don't contain carbon. Remember, our macronutrients, carbohydrates, fats, and protein all have the chemical backbone of carbon, hydrogen, and oxygen. Protein has nitrogen, and vitamins all contain carbon. So in the science, organic means carbon containing. Micronutrients, they're essential, but in much smaller amounts. We don't need them in the large amounts that we need our macronutrients. They are essential, meaning they're needed from our diet. They don't provide energy or calories. So like carbohydrates, fat, and protein, carbs provide 4 calories. fats provide 9 calories and proteins 4 calories, but no calories come from vitamins or minerals. So they're non-energy yielding. And there are 2 types of vitamins classifications. Those are water soluble and fat soluble, and we've talked a little bit about those in the fat lecture. So here is a diagram, and this shows that vitamins were initially named alphabetically in approximately the order in which they were identified. So the B vitamins were first thought to be a single chemical substance, but were later found to be many different vitamins, and for this reason they were distinguished by numbers. So vitamin B6 and B12 are the only ones that we still routinely refer to them by their numbers. So a little bit more about vitamins in our food. So almost all foods contain some vitamins, and all the food groups contain foods that are good sources of a variety of vitamins. So the amount of vitamin in a food depends on the amount that is naturally present in the food, and what is added to it, and how the food is processed, prepared, or stored. We know that fortification adds nutrients to foods, so sometimes nutrients are added to foods to comply with government fortification programs that mandate such additions in order to prevent vitamin and mineral deficiencies and to promote health in population. So the example was the vitamin D fortification. But we also know that grains are enriched with B vitamins and iron to prevent deficiency, and again that vitamin D to promote bone health and prevent deficiencies. But in most other cases, manufacturers add nutrients with the goal of increasing their product sales. This figure shows that vitamins are found in foods from all the different food groups. That's why in your nutrition portfolio assignment, you printed out your daily intake compared to the food groups. And we see that we even see vitamins in oils, but some groups are low or lacking in specific vitamins. So for example, grains, fruits, and vegetables lack B12, and grains and dairy and protein foods are low in vitamin C. So you can see why just one food group won't meet all of our needs. So fortification, again, adds nutrients to the foods. It can be government mandated or voluntary, and its goal is to prevent deficiencies leading to diseases. But we know that fortification, if you ate foods that were fortified all day long, you can actually cause a toxicity. So if you were eating, a breakfast cereal that 100% of your vitamins and minerals, and you ate that all day, every day, you would be getting, maybe 2, 3, 4, 5 times the amount of vitamins and minerals that you actually need, and that can lead to toxicities. So this is a great diagram that makes us think about critically what are the benefits and risks of fortification. So we see that the number of cases of pellagra, so kind of what happened here, and this shows the history of it, is that fortification began as a way to address nutrient deficiency. So early in the 1900s, niacin deficiency, it was as a disease called pellagra, caused more than 3,000 deaths annually in the southern United States. And then in 1938, bakers voluntarily began enriching flour with B vitamins, and that move led to a decline in mortality or deaths from pellagra. And then by 1943, enrichment of flour was becoming mandatory, and then other governments supported fortification programs in the United States happened and started helping to prevent vitamin A and D deficiencies. But we know that not all fortification is mandated by the government. So things like all these protein bars and snack bars, some beverages like all of these vitamin drinks, breakfast cereal. If we're consuming all of these fortified drinks and bars and breakfast cereals and supplements all day long, we found that a recent analysis of nutrient intake in toddlers and preschoolers showed that a significant percentage had intakes of vitamin A, folate, and zinc that exceeded the upper limits because of all of this fortification. And it can actually cause some problems, and we're going to go into great detail on that. So should the government regulate all fortification of the food? They mandated some, but now everybody's doing it. So how much is too much? And that we're going to talk about in great detail as we move on in the chapter. What about vitamin losses? Because vitamins are organic, meaning they contain carbon, they can be destroyed easily and no longer perform their duties. They can be damaged by exposure to light or oxygen. They can be washed away during preparation or destroyed by cooking. And vitamins must be handled with care during storage and cooking. So we can minimize this through food preparation methods that reduce exposure to heat and light, which might destroy some of the vitamins that are in our food. So overcooking your broccoli, boiling it till it's a deep green color. We know that most of the vitamins are lost in the water. Water-soluble vitamins go with water. So steaming, cooking vegetables al dente, so not overcooking them, can protect them from these losses. So here's some tips. Store food away from heat and light and eat it close to after you purchase it, because the longer it sits and it's exposed to oxygen and not growing as a plant, it loses its nutritional value. Cut fruits and vegetables as close as possible to the time when they'll be cooked or served. Don't soak your vegetables, because remember the water-soluble vitamins will follow the water. And cook them with as little water as possible. Microwaving, pressure cooking, roasting, grilling, stir frying, or baking rather than boiling them. And I know a lot of us are getting away from boiling really any vegetables at all. If foods are cooked in water, use the cooking water to make soups or sauces so you can retrieve some of those nutrients. And don't rinse rice before cooking in order to avoid washing away some of its water-soluble vitamins. Vitamin bioavailability, what does that mean? That means about 40 to 90% of the vitamins that we eat in foods are absorbed. Bioavailability is the extent to which the body can absorb and use a nutrient. And we know that fat-soluble vitamins are absorbed along with dietary fat. So healthy fats are good for us because they help us absorb and transport vitamins. And so the absorption of those vitamins depends on our fat consumption, which normally we really don't have a problem with. But other factors affect the efficiency of how we absorb vitamins. So that's the efficiency of our GI tract and the time of transit through our GI tract. We're going to go into specifics on that. Our previous nutrient intake and our nutritional status, other foods consumed at the same time, how we prepare that food if those vitamins are preserved, and the source of the nutrient, whether it's synthetic, if it's fortified, or naturally occurring. Vitamins are considered precursors, or some are called provitamins, and so they help other processes in the body, and some aren't active until they're inside the body. And so this is the process of absorption. Be sure to review this diagram. And we're moving to vitamin functions next.